All of that said, I don't know how to do any of that. Well, it's time to do a water check in this. For those that are brand new to this like I am, you don't really want to use pure water for very long. I'm going to, not recommended, but I'm going to use it in the water table here. You should have a high pH concentration in here with some antifungal, antibacterial, anti-mold additives to it. Last night I searched for it and found borax, actually borax soap. If you add that into water, you have to add it enough and do some test strips with it to make sure your pH is up around 9, and that will keep anti-rust and all that kind of stuff qualities in the water table. So I got my first, that's coming, but we need to do testing because come on, it's a plasma table. We got to see how it works. And I actually figured out how to get SolidWorks to generate G-code. So I think I have a file loaded and I think it's set up, and I've simulated it. I'm going to show you that. So we're going to try it. We'll see what happens. But let me get more water and we'll give it a shot. So the plasma cutter is off and I have everything zeroed and set. So what we're going to do is actually run through a cycle here. It is simulating. If the plasma cutter was on, it would be cutting right now. So what I'm looking for is to make sure that that tip isn't going wonky in different places where we don't want it. It's going through and making all the cuts right now, the outer perimeter, and now it's cutting the inner. I'm excited for this. I am excited. I'm excited. And the only problem I think I might have here is that this is a drag tip, and we're going to see if that works or not. It may not. And it worked. So this is the big moment. That's a good starting sign. Oh, there's a bunch of electrical right there. Let's move all the electrical out of the way. So this is why we do it. It's going through its natural startup cycle here. All right, and there's electrical. I did a safety pass on the floor. Let's get that up off the ground. Just use this for right now. So that's important to know. As far as safety goes, safety goggles, check. Ventilation, check. Swept the floor around the area, check. No flammables. Fire extinguisher right there. I don't think we'll need it. Emergency turn-off button is big, giant red thing right here. I think we're at the point where we're going to turn this thing on, and it'll either work or it won't. Oh my goodness, I'm so nervous. All right, let me make sure I got you a good shot. All right, standard prayer. Oh Lord, don't let me screw this up. Ready? Begin. I don't think it's cutting all the way through. I need hearing protection. Oh, it's moving too fast. Glad I did that safety walk. There, it made it through that time. Woo! Look at that. So, you can clearly see that we were going way too fast on the travel. Boy, those lines right there, they look nice. So we got to slow that travel down quite a bit. That looks cool though, man. I'm going to keep that. I'm going to keep that because that is way cool. You can see we didn't penetrate. Okay, so that's the very first time I have ever used a plasma cutting table. Way cool, man. I am so stoked, obviously, for what this thing can do. Now what we've got to do, so we've got to figure out the right settings for this particular cutter. I reached out to Cutmaster Thermodynamics, and they don't have the cutting recommendations for the Cutmaster 42 set up as a machine. And they don't want to give it to you because it's not how you're supposed to use the machine. Even though it is, from a Langmuir standpoint, the Cutmaster works with the table, obviously. They don't want, it wasn't designed for a machine-based thing. We modified it, you saw that modification, so they didn't want to give me the information. That was a while ago that I asked them. So I got some of the information for the Cutmaster 52 and the Cutmaster 60, and what we need to do is figure out the right travel speed based on these different settings, the different types of metal. This is 1/8 inch thick, standard steel, nothing special about it. I think if I was using, ooh, we should try that. Yeah. If I was using the stainless steel sheet, I don't have any other sheeting to use, that's what I was just thinking about. We could potentially try that. Another thing that could be an issue here is that I have, this is a drag tip, and we're a little high. You know, I think we should try that. I think it's still gonna be too fast, but we're gonna try it anyway. I think I should lower the tip. That was way off. All right, so we're gonna use their rules first, because I thought I did that. Pretty sure I did that. All right, so now we're set. All right, so we're gonna do the same thing here. We're gonna do the practice run first. Oh, that was way messed up. Yeah, there's a bow there. All right, we got to fix that. All right, that looks good to me. Test complete. Trigger installed. We're on. Safety check. Electrical is out of the way. Fire extinguisher, ventilation, goggles. Let's roll. It's not going through again. It should have stopped when it jumped too. That's another setting issue. There, it went through that time. Woo! We're cutting metal, baby! All right, another good learning experience. So there's a few things. One, the torch, it should move to its spot and the torch should start and then it should move. It also should have turned off when it jumped over into the text, and it didn't do that, and it's not turning off when it jumps between each of the letters either. And we're still having a hard time with it. I think it's still too fast. Too fast. So for those that were wondering, yesterday we were doing a 3D print, and man, it was going really, really well. But unfortunately we had a failure last night, not because of settings of the printer, but because, because the spool that's on the side of the machine, we went with a smaller spool instead of the big one for testing. It actually fell off of its spindle, fell to the ground, created a bind, and the thing stopped. So we're reprinting that grow box. So we keep running in these types of issues. So far though, things are looking good today. Waiting to hear back from the manufacturer on the settings and everything we've done. Again, they're sending me a new fan for it as well to help deal with this issue, the heat. So figuring stuff out, figuring tools out, that's what we're doing here. What we need to do right now, I want to show you what I did. So this is SolidWorks. Make sure you guys can see that okay. So what we did, went into SolidWorks, created a really simple part, what you saw. This is what it's supposed to look like when it's done. SolidWorks has built-in CAM, computer-aided manufacturing, so you can do all this on the version of SolidWorks, which you guys can get, like if you're a veteran or a student, you can get SolidWorks, and I highly recommend it. Here's the CAM toolbar, and then what we do is you go in, we have to set up the machine type, so I followed some instructions online for how to do that. Let me show you. you go to the technology database, and then you actually copy the basic mill machine that uses inch, and you create a plasma, and you tell it to use the Mach III post-processing, which is what we did here. And there's a bunch of other stuff that you don't need to set up. Then you need to go into your mill tooling and choose a flat end mill. I went with the smallest diameter one and copied it. And then you set up the plasma. And, oh, the kerf. I've got to go measure that kerf. So I didn't know what the kerf was on the Cutmaster. So now that we have that, I need to go measure that. But I set it at 0.06, which is just slightly larger than a millimeter. That's the one thing you have to set up in here. Once you get that all set up, you can go back to your mill, and then go to your tool crib, which I have no idea what that is. I think it's where the tools are stored in the CNC machine for which ones it grabs and all that. But for us, we just needed to tell it to grab the tool we just created, which is the plasma nozzle. So right now I'm 120 volts AC pumping into that thing, and we can do the 200. We can do 220 volts, 240 if we need to. And I think the only standoff tip I have is actually 240. So we might jump over to that. But I kind of want to play here with the 120 first. Once we get everything all set up, we tell it what type of stock we're using here. In this case, we're doing, well, we're not doing stainless right now. We're doing, where's just basic A10. There's A10 steel right there. We'll just go with that. And then you create an offset to deal with, inconsistencies and making sure there's enough wiggle room, if you will, for it. And I think I may have actually screwed that up a little bit. I put a Z. That's not right. Something's going on with my coordinate system. So you also have to set up a coordinate system. Oh, that one's set up right. All right. So yeah, this is just this one here. There's a Z offset, and there shouldn't be. That's still there. Oh, that was a Y offset in this coordinate system. Coordinates, man, you gotta love coordinates. All right. So there's that. That could have played into it. And then you tell it where the starting point is at. You set up your coordinate system here. Make sure Z is coming up out of the part. And then you tell it to extract the machinable features, and it figures out, what things you want to do. And then you generate the tool path, and then we can actually simulate it here, and we can see the tool going through and making all the cuts that it's supposed to do. Now the problem that we had again, I think, is that we're moving way too fast. And I also think I probably want to mess around with that offset. Let's see, simulate tool path. See, it's supposed to come in here. It should have turned off. Oh, what are you doing? It should have turned off the trigger. And it didn't do that, remember? And it started late, so it got over there, and we need to add a little delay. I need to take some notes. We're gonna have to mess around with the G-code. So we need a start delay. And then we need to turn off between parts. Cuts, I should say. And then start delay. So we need to do a move, start, wait, go, turn off, move, start, wait, go. And then we'd be rocking and rolling. And then we got to look at speed as the things to do. Now, all of that said, I don't know how to do any of that. So I'm going to go off camera and I'm going to figure that out. And I'll let you guys know what the summary version is after we figure it out. Oh, there's so much. But it's still so freaking cool. So cool. Crank up the tunes. All right. I've been working on it for quite a few hours, learning G-code, which is the language, the machine language that tells it how to do everything out there. I've been testing a little bit off camera, and I think I got one dialed in here. What I've had to do is get everything set up in SolidWorks and then edit the G-code directly, because I need to turn the tool on and off at different times, which SolidWorks didn't do. And I also need to put some pauses in there and change the speeds to compensate for the machine, which I should be able to do in SolidWorks, but I haven't figured out yet. Regardless, let's go see what I got. All right, safety is ready. Everything's set up. And we're gonna go here. Beginning, pause, cut, a lot slower. We're definitely penetrating now. I think that might be too slow. Oh, no. This is 1/8 inch thick steel we're going through. That's not bad. It had that one little hiccup there. Lines are nice and straight. Now it's on top again right there. I didn't like that. Oh, I'm doing wrong there. There, it punched through. Okay. Now it's off like it's supposed to be. Now we go next. Pause. It didn't make it through. It's just not punching through. There, now it punched through. I think I gotta have a longer pause at the very beginning so it gets hot, and then go. So that one's looking good right there. Back on top. And I think we gotta go slower still. There, punch through. Too fast. Oh, just blew a breaker. So I just want to say up front, I really am pushing it with 1/8 inch steel. So I did a try earlier on the stainless that I had, and it cut it. So I'm actually gonna move this out, and I'm gonna bring the stainless back in and see how it does, because I think it's just a matter of figuring out the settings for 1/8 inch. And when I'm just on 120 volts, I think I'm pushing the 1/8 inch thing a little far. It is cutting through, and I think if I slow it down far enough, it'll be fine. But let's put some stainless on there. I think I got a few more test cuts, and we'll see how it does. All right, this is 24 gauge stainless steel, and I'm pretty sure we got it set to go too slow, but it takes a while to redo the G-code file. So we're just gonna give it a shot and see what happens. Nothing. Why is that? I did something wrong. I gotta reset after the breaker. Okay. Going. That punched right through. This is the gauge steel I will be cutting. So getting this figured out is really the mission critical part. It looks like I'm a little far away on the tip. Yep. All right, so I popped the breaker. I'm pretty sure it's because I was too far away from that steel. So because I took a break, I went in and updated the G-code. Right now we're doing a test on the updated G-code. You can see it's moving a lot slower. I just got to test the extent here, which should be coming up shortly. And then we'll be able to get to an actual cut, which will be exciting. I also added a little bit more delay in this startup sequence of the torch. So it should do us well. And we do have this metal is still bent. So we're kind of, oh, that's gonna go right up into there. Oh, it's right to the very edge of it. Okay, plugging her in. Torch is active, safety is still safety. And we're gonna go. Let's go. Torch is on, pausing a little bit longer. Burn through, now we're going slow. I think I'm still a little too far off on that torch. But that's cutting through. Ah, damn breaker. I don't know why I'm popping breakers, but I am. All right, I had to get a different piece of steel because I've tested too much. This one's just a hair thicker. We're gonna see what happens. Here we go. All right, we have circuit breaker configuration number 2064. Ready, begin. That's previous cut. Now we're in a virgin metal. That's cutting right on the support stand as well, and it is cutting through. You're gonna run out of air. Kiss can't handle it. I keep popping breakers. I only got a 15 amp breaker and a few 20 amp breakers. Gonna have to fix that problem. Not going too fast. We might make it through. All right, now we just made it to the next one. Start, burn through, just burn through. At this point, we're hoping we don't run out of air. If we do, then it's gonna shut down by itself, but we're still pumping. It's hardly using anything. So slightly over 1/8 inch thick steel here. On a 120 volt plasma cutter. I'm so tempted to take my glasses off so I can see it, but I know I get flashed. Nice. Burn through coming, burn through. Oh, way too fast. Whoa, what the heck is going on? Obviously that one has not been updated. Oh, man, we almost had a perfect cut. Oh, bummer. All right, folks, we're doing it again. I think we got it this time. But let's find out. Loading G-code now. Take number way too many. Safety's on, glasses on. Oh, whoa, stopping. Stop, oh, whoa, 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 whoa. Whoa. Forgot to reset home. Here we go. Resetting home. All right. Take 2000. Going. But you can see the value of that water table. Thunderstruck's playing in the background, guys. I love that song. So tempted to take my glasses off so I can see better. Oh, you can't do that. All right, here we come. Nice, nice, nice. Reset. Burn through. Good. That initial burn through spot, not so nice. A lot of slag catching up on the top side. Oh, that was a little fast. That was a nice cut through. Same thing, that first cut's a little rough, the punch through. I'm not sure we're getting a clean cut. It looks nice, but I think we're getting some re-weld because it's so small. Yeah, it looks that way. That is so cool. This is where somebody should comment. Technically speaking, it's really hot. Yes, yes. Oh man, I made it right to the end and popped a breaker. We're now on 220 with a standoff tip. I only got 2 of them. I think we are ready to go. Let's give it a shot. We might have to stop this one fast. Well, it's not even going. Well, that makes that easy. Why are you not going? Oh, because you're not on. Ah! Okay, here we go. Go to 0. On 0. Ready to start, green light go, safety in place, get ready to stop it. We could speed that up now, can't we? You gotta love 240. That's going to be too hot. It's going too slow. I think for when it does the letters. Looks like I'm up a little high. I could probably lower that down a little bit better there and get even better arc. It is a standoff tip, so this is meant for this. That's nice. Re-weld. A little too slow, I think, now. Well, we learned a whole lot today. We learned about G-code. We learned about how to program in G-code, how to modify G-code, how to add a pod, how to add a pause so it can burn through, how to turn the torch on and off. We learned about Solidworks and CAM, and we got that going, though there's still a lot more to learn there because I shouldn't have to edit G-code. It should come right out of Solidworks that way. We learned about the different settings, speeds and everything that we started off with, and we eventually got up to where we're even using 220 on these. And I did notice here on the back, look at all that slag on the back. I think that means we're going too slow now. Too hot and too slow, I think is what that means. So we'll have to check that out. That certainly isn't the way we want it to look. We want it to be nice and clean. So you guys that know better, tell me what too much slag on the back means. Again, they don't have a book on this particular plasma cutter, so I can just get all the settings dialed in. So that's why we did all the trial and error today. But hey, we made it this far, and I'm pretty confident we can make it a lot further. So thank you again to the subscriber that sent this to me. That is just so amazing. We're going to make great use of this. Remember, what I'm going to be using it for primarily is cutting the stainless steel here, which I did this one with the default settings out of SolidWorks, and it was going very nice. We just need to, in fact, I'll probably go play with that again here tonight, but that's what we need it for. We need it right now so we can trim anything that needs to be trimmed and not have to do it by hand. You know, this will be nice and sharp. So if we do have to trim any of that metal because of a mistake on my part, we'll be able to do that really easily now. We can fabricate so many parts. We got the soap coming, the borax, so we can put it in here and crank the pH up on this thing and actually be able to have the water in here and not rust everything out. So I do need to drain that and be ready to use it again. But just amazing. What an amazing tool. And to be able to convert the Cutmaster 42 in here and use it like this, just really, really amazing. So thank you again. You know about Facebook, Twitter, and Instagram. You can follow us there. And if you really like what we're doing, what we're seeing, you can help us on Patreon. $1 a month goes a long way for us. If you do choose to do that, thank you in advance. And for everyone who is on Patreon helping us, thank you. Really appreciate your continued support. In the meantime, everybody, this is Real Martian, out.